Hello, can you hear me? And can you see my screen? Okay. So let's start our today's training. Today I will introduce interposition mode of our driver. And this interposition mode is we have this mode in VD2 series, VD2 and VD2F. Okay. And here, first I will introduce this internal position mode first, and then I will introduce the three running modes of our internal position mode: single operation, cyclic operation, and PI switching operation. First, for example, here we have this case. The products need to be sockets in four different liquid, and for each one we need to socket time is different. So you can see from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and totally here we have 12 displacements about one cycle. Okay, and for each cycle the operation is same. So in this application, we can use our internal position mode, and we can set here segment 1, segment 2, 3, 4. For each segment, we can set the distance, set the speed, and set other running parameters, and make our products running like this, step by step, and cyclically running. So with this, we don't need to connect PLC to do the logic control. Here is the introduction about our internal position. First, this internal position we can support max to 16 segments. And in the three operation mode: single operation, cyclic operation, and DI switching operation. For each segment, for each movement, we can set 4 parameters. First is moving distance and running speeds, acceleration, deceleration time, and waiting time. Here you can see segment 1, segment 2. And this is the waiting time. Waiting time is the time between 2 segments. And this is the running speed of segment 1. This is running speed of segment 2. And here, this acceleration time, you can also set it. And this is our moving distance, because this is a VT curve. So we can know this area. This area is the movement. And for here, 3 operation modes. The first 2, single operation and cyclic operation. For these 2 operations, we can set the start segments number and the end segment number. How to say? For example, we have 1, 2, 3, 4, and 16. We have 16 segments. For example, we only want to run these 3 segments, and cyclically or single. So we can set the start segment as 2 and the end segment number as 4. So in this setting, when we run the single operation, our servo, our motor will run segment 2, segment 3, and segment 4, and then stop. This is single operation. For cyclic operation, after 2, 3, 4 running finishes, the motor will continue to run segment 2, and then 3, and then 4, and like this. We're cyclically moving. So for these two modes, we can set the start segment and the end segment number. And the last operation is DS switching. DS switching means we can use four external terminal to demand which segment to run for currents. And later we'll have a table to show this DI running. And here have 3 points need to note it. First, for VD2 and VD2F, only the firmware after V1.10 and VD2F is after V1.00 supports internal position control. And the VD2 B-type incremental driver doesn't support this function. Only absolute type driver support this. Okay, now you can yes, this cable. This impulse 4, impulse 3, impulse 2, and impulse 1 is our DI function code. It is here 21, 22, 23, and 24. It's for function code. Okay, so here we can see for example, we use here we use DI1. We use DI1 for this code, and then use DI2 for impulse 2, and also okay. So here, if the status of this 4DI is 0, means there are no inputs, then our server will run the segment 1, and after segment 1 finishes, the motor will stop there. And for example, if we want to run this segment 10, for example, how to run segment 10? You can see here we need to give a signal to DI4, make it turn on, and also give a signal to DI1 to make it turn on. So you can see, and for these two, we should give no segment, no signal. So in this status, we can run this segment 10. Okay, so you can see we can select the segment to run by changing the DI status of this 4DI. This is how we switching the segments by DI. And here is the steps about how to set parameter for this internal position. Yes, you can PLC code. You mean by communication, right? Yes, you can, because I have said or for DI. For DI inputs, here we have a input source selection. Here have yes. First for RS485. First, for example, here for DI, you can select the input source selection as virtual DI input, and then you can use communication RS485 communication or SC tool to change the value of this one. If here if you change this virtual DI1 input value as 1, means we are giving a signal to our DI1. This is for virtual DI. And if you want to use PLC outputs Y terminal to change the segments, here you need to select hardware input type, and then use PLC to change it. Okay, understand? Yes. And for the modbus address of this P13 group, you can check the modbus address in our Wecon Support Center. Okay. So here let's continue. For this function, how to set the parameter. First, we need to set the roaming mode. We need to set the roaming modes. First, here we need to select position control, and then here position commands. Here we need to select internal position command. This is the first steps to set the correct running mode. And then second, we need to set the DI. First, we need to set use one DI to enable our servo. And usually we use DI1 because DI1 is default function code. Default function code is 1. Okay, this is the first step. We need to enable the servo. And the second step, we need to use another DI to enable the internal position mode. Here you can see, here we have a function code 20, and it means internal multi-segment position enable signal. So after we give the servo enable signal to make the servo in run status, we still need to give another signal to for this function 20. So here we need to use another DI. And set this DI function code as 20 and give signal to this 20 to this function. Sorry, to this digital input. And then our driver will begin to run the internal position mode. So you can see here, okay, I set DI2 as 20 for this code. This is for internal. This is for enable. And next, if you are using DI switching operation modes, you need to select another DI to avoid it. But how much DI you need, it depends on the segment you using. For example, you only have we can check this table. Here you can see for two terminal. For two terminal, you can achieve 4 segments of switching. And for 3 terminal, you will get 0, 0, 0, 1, 1, 1. Here is 8 segments. And for 4 terminal, you can get this range, and this is 16 segments. So you can see 1 DI we can set 2 segments, 2 DI we can set 4 segments, and the 3 DI we can set 8 segments, and the 4 DI we can set max to 16 segments. So we don't need to configure all this for our application. It depends on how many segments you are using. Okay. Okay, so here after set the DI inputs, then we need to set parameter P7 group. Here have many parameter. First, here you can see from here 9, 10, 11, and 12. This 4 is used for 1 segment setting. As I said, we can set 4 parameter for 1 segment. This is moving distance, running speed, and acceleration, deceleration time, and waiting time. You can see for each segment, we have four parameters to set it. And here totally we have 16 segments. So below setting are same, but how can we get 8 or 16 as we are using the I1 for you need to use another 4. For example, if you want to get 8 segments, you need to use 3 DI. So you can use DI 3, 4, and 5. These 3 segments, these 3 DI to switch it. Because for VD2 series, we have max to 8 DI. So if we use 2 DI for enable, we have another 6 DI for this setting. Okay. Yes. Here. Yes, here first one is use this P7 and 1 is used to select the running mode. Here we have 3 modes. Okay, and the next 2 parameter is start position number and end position number. And these 2 parameter only take effect in single operation and cyclic operation. So for example, here we set start and end position number as 1. It means when we run the single operation, the motor will run this first segment. this first segment, and after running, it will stop. And if here we are selecting cyclic, then the motor will run segment 1, and after the waiting time, and then run this segment 1 again, cyclic running. So we can change the start and the end number to select which select the range to run. Okay. And for P7 and 4, this means, for example, for 0 means run the remand position, and 1 means run from the first position. You can check in this picture. For example, we have totally 4 segments. And when the servo run segment 2, here we power off, or disable the servo. And the next time, sorry, not power off, just here, disable the multi-segments enable terminal. If we disable it, and then after a while, we enable this segment again. Enable this signal again. You can see the motor will, the driver will continue to run segment 3 and segment 4. This is we call running the remaining segments. But for this setting, this is cyclic running. This cyclic running, you can see after, for example, we disable in segment 3 and enable again. The motor will run from the next segment 4, and after it finishes from segment 1 again and 2, because this is cyclic running, and this is the single running. So after segment 4 finishes, motor will stop. But here different. Motor will continue to run 1, 2, 3, 4, 1, 2, 3, 4. And the next is, we call it running from the start segment. So you can easily understand here. Same. For example, here we run in segment 2, we disable the servo and enable the servo again. The servo will run the first segment from, and then continue to run. And then also same here. So it will not to run the remand segment. This is the difference. And the P7 and the 5. P7 and 5, this is relative move and absolute move. The difference is just like our DDRVA and the DDRVI instruction. For example, for this default parameter, if we use relative position command and then run all these 16 segments, and at last our driver will stop and yes, stop. Sorry, not stop here, because for each segment is 10,000, and we have 16 segments. So finally, the motor will stop here. But for absolute running, the motor will run from 0 to 10,000, and for below segments, the motor will keep here because it is absolute 10,000 position. So the motor will not running. This is the difference about the position instruction type. And the last is this waiting time unit. We can set it as S seconds or ms, and this unit is waiting time, working here. P7 and 12 is the waiting time or for first segment. And P7 and 16, this is the waiting time for segment 2. And this is for segment 3, segment 4, and so on. Okay, so this is all parameter about internal position control. So you can see it's not too much, yes. And now we can see for single operation. It's a single operation. The motor will only run from start segment and start segment to end segment and then stop. Only one cycle. This is the parameter setting. So you can see it's very how to say, it's very details. First, this is for position mode, right? And this is P0 and 16. Do you remember what's this parameter used for? This parameter is PPR of our motor. So and the default is 10,000. So here, so in group 7, here you can see for each segment displacement here also 10,000. So it means the motor will run 1 turn. Okay, 1 turn. And this is our position source. 1 means internal position mode, and 0 means post control. And the next, we need to set the DI. Here, DI2, DI3, and DI4 set 1. Why set like this? First, DI2 is used for enable, and the DI and here this is logical, and this is the control source. 1 means virtual setting, and 0 means hardware input. So if you don't have PLC, for example, you only have HMI, so you can set like this. Set the DI terminal with virtual input, and use HMI to change the virtual DI status through motor bus RS485. This is for enable servo, and this is used for enable the internal mode. You can see here function code 20. Function code 20. It's this one, internal multi-segment position enable. And after this setting, we need to configure our movements. So you can see all this parameter is used for our segment setting. Sorry, not here. And after setting this segment parameter, here step 6. Step 6 is used to enable internal and position signal. But if you are using as I said, if you are using hardware inputs, so you don't need to do this step 6. You can directly use use PLC outputs to enable the servo. Do you have any questions about this parameter setting? If no questions, I will continue for next part, cycling operation. Okay. And the next is cycling operation. The only difference is after the servo finished in the last segment, the servo will continue to run from the second segment, first segment. So it's a cycling move, and all these parameters configuration is same. This part is same, and here is same. Here used for enable our servo. This part is also same. Only different is this one. Here we use set it as 1. 1 means cycling, 0 means signal, and 2 means DI switching. And for other setting is also similar. This is 5 turns, and this is the acceleration deceleration time. This is the waiting time. Yes. And this is our this is the speed, and this is waiting time. 60 means 60 RPM, and 100 means 100 ms waiting time. Okay, and the other setting is also similar. The only biggest difference is this parameter is different, P7 and 1. Okay, and then we can check DI switching. Yeah, DI switching. Yes, this picture you can see here for different DI status. The servo will run different segments, and as we said before. Okay, and and here this part I think I described wrong just now. Just now I said for columns operation. So sorry, for column segments, if we didn't change the DI status, the servo will run column segment cycling, not stop cycling. So it means if our DI status is 0, 0, 0, 0, and the servo will run segment 1, and after the waiting time, the servo will run segment 1 again, and after the after the waiting time, the motor will run segment 1 again, like this. And here I have another point need to notice. For example, we are running segment 1, and in the middle, if we change the DI status to make the servo to run segment 2, the driver will first finish current segments, and then to run the new segments. So you can see the change of DI status will not take effect immediately. It will take effect after the current segment is finished. And this is for DI switching. de-acceleration operation setting. First, this part is 10. And also this part is 10. Enable, used to enable. And here, yeah, I think here setting is wrong. Wait, let me modify it. Here for P7 and 1, we should set it as 2. So this is wrong. Okay. And P7 and 2. P7 and 2, P7 and 3. For these two segments, for these two parameters, you can set it or not, because in fact these two parameters will not take effect. So I think we don't need to set it. And the next, this is instruction type, relative or absolute. It's dependent on your application. And the last 7 and 6 is the unit. And here you set 0. 0 means MS. And here, you can see here, we need to set many DI terminal for our internal control mode, internal modes. 21 and 22, 23 and 23. Okay, here only have, and also 24. This is 1 DI, 2 DI, 3 DI, and 4 DI. Here, configure all 4 DI for the internal modes. But as I said, it's dependent on how much segment you are running. So if the segment is only a little, maybe you only need to set 1 or 2 DI to switching. And the last is the parameter for the segment setting. This part is 10. And also step 7 is used to enable the servo if you are using virtual signal. Okay, so this is all setting about internal position mode and the DI switching. Okay, we tell how many positions we want to let the. You mean in DI switching? In DI switching, the motor will stop. How to say? There are two way to stop the motor. First is disable the internal position mode signal. I mean that's function code 20. This is first one. First way to stop. And the second way you can set one segment. You can, for example, you can set segment 1 and set the distance at 0. So for example, you are running segment 2, segment 3, and for now you want to stop. Then you can switch to segment 1, and then the motor will stop, because segment 1, our target moving distance is 0. Cyclic operation, which here for first parameter, P7 and 1. Here I think you can select the cyclic operation first, and then you can set the start and end position number as 3. So your motor will run segment 3 cycling. Do you understand? Yes. Okay. So what about other people? Do other people have question? Because our today's homework where I will give you a homework to run this internal position modes. I will give you the parameters about. I will give you some, for example, segment 1, you need to run in 100 RPM and run two turn, and for segment 2, you how to run. And for example, I will give you some segments to run and use DI switching. So you need to change the DI status to change the segment running and record it. This is about our today's homework. Because compared with position post control and position cost control and speed control, there are a few parameters to set. But for internal position mode, here we have maybe more than 10 parameters, or maybe 20 parameters need to set. So if you have any questions, you can ask now. I think it's not difficult, but maybe only take more time, maybe 20 minutes or 10 minutes or 20 minutes to finish it. But in fact, it's not difficult. Okay. And everything is clear now. Let's see how it comes during our homework. Thank you. Okay. And in fact, if you meet any questions, you can ask me in our group, and also you can check the presentation again. In fact, you can see here have very clear parameter setting. Okay, and that's our today's training. And next week we will have another last three class for internal speed and parameter adjustment too. And the last, I will give a class to answer your questions about our training from day 1 to day 10. And also I will give some give some, how to say, some comments on our homework from day 1 to day 10. Okay, and finish it. It's all. Then we can begin. We can begin our last testing, last exam for our servo training. Okay, and let's. Oh, thanks for your watching. See you next week, and have a good weekend. Thanks for attending. See you next time. Bye, goodbye.